Hi friends, in this tutorial we'll be implementing distributed log tracing for microservices using Spring Cloud, Sleuth and Zipkin. For this I'll be taking reference of my website javanews.com. So go to Spring, Netflix Spring Cloud. The example that we are going to see today is Spring Cloud tutorial distributed log tracing using Sleuth and Zipkin example. I'll be sharing this URL along with the YouTube video. Let us first have a look at what is distributed log tracing and what is the need for it. Usually for systems developed using microservices architecture, there are many microservices involved. These microservices, they collaborate with each other. Consider the following example. So here we have 9 microservices which are collaborating with each other. But in real world example, there might be hundreds of microservices involved. If suppose during one such call execution, there are issues like an exception has occurred, or maybe there are latency issues due to particular service taking more than expected time. Suppose a call is made to microservice 1 and during this execution, suppose microservice 5, it is taking a lot more time. Then how would we know that microservice 5 is causing the issue? In a regular project, we would have used logging to analyze the logs to know more about the exception occurred and also about performance timing. But since microservices have multiple services, we cannot use regular logging because each service will have its own logs. So in this case, microservice 5, if it is causing the issue, still we'll have to check the logs of microservice 1, 2, 3, 5 and all the microservices involved, and then figure out like which microservice is taking more time. Also, how do we correlate the logs to a request call chain? That is, which logs of microservices are related to request 1 and which are related to request 2. To resolve these issues, we make use of Spring Cloud, Sleuth and Zipkin. Spring Cloud Sleuth is used to generate and attach the trace ID, span ID to the log so that these can then be used by tools like Zipkin and ELK for storage and analysis. While Zipkin, it is a distributed tracing system. It helps gathering timing data needed to troubleshoot latency problems in service architectures. So these are just the definitions. We'll be looking at more detail as to how Spring Cloud, Sleuth and Zipkin help us resolve this issue. So let's begin with the implementation. The implementation part, we'll be dividing it into 3 sections. First, we'll be developing 4 Spring Boot microservice modules which interact with each other. Then we'll be implementing distributed tracing using Spring Cloud Sleuth, and finally we'll be viewing the distributed tracing using Zipkin. These are the 4 microservices that we'll be developing. User will be making a call to microservice 1 using the URL /microservice1. Microservice 1 will in turn call microservice 2, which will in turn make a call to 3, and finally a call will be made to microservice 4. Microservice 4 will return a response to microservice 3, which will return the same response to microservice 2, which will again return this response to microservice 1, and finally this response will be returned back to the user. So whenever the user calls the microservice 1, this complete request chain, it will get fired. Let us create these 4 microservices. Go to Eclipse and create a new Maven project. Create a simple project. At group ID, I'll be giving it as com.javanews. Artifact ID, I'll be giving it as microservice1. Next, we'll be adding the required dependencies. So go to the pom.xml, and from here we'll be copying the required dependencies. So we are going to add 2 dependencies. One is the Spring Boot Starter Web dependency and the other is Spring Boot Starter Log4j dependency. So copy this entire thing. Next, we'll be creating the application.properties. It will be having 2 properties. One is the port on which the application will be starting, that is 8080, and the other is the application name, which will be microservice 1. So go to Eclipse and create a new properties file. Name it application.properties. And copy the content from here. Next, we'll be creating a class named microservice1 application. This will be a bootstrap class, so we'll be annotating it with the Spring Boot application annotation. Also in this class, we'll be creating a controller and we'll be exposing a get REST API with the mapping microservice1. Also, if you have seen here in the diagram above, the microservice1, it will be making a call to the microservice 2. So this call to microservice 2 will be making using the Spring REST template. So this is the class that we'll be developing. It will be having the Spring Boot application annotation. Also, we'll be creating a controller, so we have used the REST controller annotation, and here we are exposing a REST API with the URL microservice1, and using the REST template we are making a call to the second microservice that we'll be creating next, which is having the URL microservice2 and it is deployed on port 8081. So let us create this class. Go to Eclipse and create a new class. The name of the class will be microservice1 application and the package will be com.java in use. Copy the contents of this class. We are done with creating microservice 1. Now let us create the other 3 microservices. So for this I'll be just copying this microservice 1 and creating the other microservices structure. So the name of the other microservice, it will be microservice 2. I'll be creating 3 and 4 also. Microservice 3, and we'll be having finally microservice 4. So we have created the other microservices structure. So let us make some changes in that. The name of this will be microservice 2. So make this change in the pom.xml. Next, go to application.properties. We'll be deploying this microservice on 8081 and this will be microservice 2. Finally, I'll be renaming this class microservice 1 application as microservice 2 application. Finish. I'll be renaming the REST controller to microservice 2 controller. Rename this method 1 to method 2. The mapping will be microservice 2. Also we'll be calling the third microservice which will be deployed on port 8082 and the URL will be /microservice3, and we are inside method 2. I'll just change a little bit of logging. So we are done with the changes for microservice 2. We'll have to make similar changes for microservice 3 also. So go to its pom.xml. This will be microservice 3. Next, go to source main resources and application.properties. This will be deployed on 8082 and it will be microservice 3. Next, I'll be renaming this class to microservice 3 application. Finish. Inside I'll be making similar changes that we made for microservice 2. So this will be microservice 3 controller. This will be method 2. This will be method 3. We are inside method 3. We are changing all these methods names because it will be easy when we are seeing the logs. Next, it will be calling microservice 4 which will be deployed on 8083 and it will be microservice 4. And yeah, we have left this. So this will be microservice 3. Finally, we'll be making changes for microservice 4. So go to the pom.xml. This will be microservice 4. Go to source main resources, application.properties. This will be deployed on port 8083. This will be microservice 4, the application name. Source main Java, change this to microservice 4 application. Inside we'll be changing the controller name first. So this will be microservice 4 controller. We have exposed this REST endpoint with microservice 4. This will be method 4. Inside method 4. Also, this is the last microservice in a chain. So it will not be calling any other microservice, but instead it will be returning the response which will be consumed by the other microservices. So here we'll just be returning a response which will be hello world Java in use. Remove this log statement. So we are done with the changes. We have created the 4 microservices. Let us start all these. So run as Java application. Similarly, start the second microservice, third, and also the 4th microservice. So all the 4 microservices have started. So we'll now make a call to microservice 1 which will make a call to 2, 3 and 4, and 4th microservice will then return a response which will then be returned finally back to the user. So let us make a call to microservice 1. Type in localhost 8080/microservice1. So here we are getting the response hello world Java in use which has been returned by microservice 4. Also in the console we can see the log statements. So here we have inside method 1 and the response received by method 1. Similarly in microservice 2 we'll be having inside method 2 and the response received by method 2. We'll be having microservice 3 similar logs, and finally in microservice 4 we'll be having only inside method 4 logs. Usually in real world applications, each of these 4 microservices, they will be having their log files at different locations, and we'll have to go to each log file to check the logs. Also suppose if there are multiple requests that have been made, so suppose multiple requests have been made to microservice 1, then we'll not be able to correlate the logs of each of these microservices. So suppose inside method 1, now after this call is being made to which logs in microservice 2, we don't know, since there are multiple logs in microservice 2. Similar is the case with microservice 3. We'll not be able to trace the request chain once it is made to microservice 1. Next we'll be implementing distributed tracing using Spring Cloud Sleuth. Using Spring Cloud Sleuth, we will be adding unique tokens to all the requests. Spring Cloud Sleuth is used to generate and attach the trace ID, span ID to the logs. So this is the token that we'll be attaching to all our logs. The Spring Cloud Sleuth token, it has the following components. The first is the application name. So it is the application name that we have defined in the application.properties. So we have defined application name like microservice 2, microservice 3. So this will be the first component in the Spring Cloud Sleuth token. Then we have the trace ID. This trace ID, it is added by the Sleuth itself. It is self-generated by Sleuth. This ID is same in all the services for a given request. So a particular request, when we have hit microservice 1, it will call microservice 2, then microservice 3 and microservice 4, and also then we'll be having a response sent from 4 to 3, then from 3 to 2, and from 2 to 1, and finally to the back to the caller. So this entire chain, it will be having the same trace ID. So this trace ID, it will be the same throughout all the different microservices. Then we have the span ID. The span ID is again added by the Sleuth. It is self-generated by Sleuth. This ID is the same in the same unit of work. That is, in our case, it will be same when the log statements are printed in the same method. So for our case, method 2 that we have defined in microservice 2, it will be having the same span ID. Similarly, method 3 that we have defined in microservice 3, it will be having the same span ID. Finally, we have the Zipkin export flag. This boolean flag indicates whether the span should be exported to Zipkin or not. Let's begin with the implementation part. We'll first need to add the required dependencies to the pom.xml. So we'll be modifying the pom.xml of all the 4 microservices. This is the Spring Cloud version that we are going to use, greenwich.sr2. So go to the pom.xml and add this property in each pom. Go to microservice 3 and add this property. Finally to microservice 4. Next we'll be adding the Spring Cloud status load dependency to each pom.xml. So this is microservice 4, so I'll be adding here in the dependencies. Add this dependency. Microservice 2 and microservice 1. Finally, we'll be adding this dependency management that is needed whenever we are using Spring Cloud. So add this section to each pom.xml. This will be after dependencies. In microservice 3 again add it, and finally in microservice 4 add it. If the Eclipse does not download this dependency automatically, just do a maven install. This will download the required Spring Cloud dependency. So here it is downloading the Spring Cloud dependency. Next, in the application.properties, we'll be adding this property Spring+Zipkin enabled is equal to false. In the second section, we just want to make use of Spring Cloud Sleuth. In the next section, we'll be making use of Zipkin. So if we don't add this property, we get an exception that Zipkin address is not given. So currently just make it as false. In the next section, we'll be enabling this. So go to the application.properties of all the microservices and add this. Next we'll be modifying the microservice application class of all the 4 microservices. So in a distributed tracing, the data volumes can be very high, so sampling can be important. So what do we mean by sampling? In the microservice application class, create this bean. You'll have to import this dependency. So do this for all the microservices. Let us import this. Go to source main Java, microservice 3 application, and create the bean. Again make an import. And finally for microservice 4, again create this bean. We are done with the changes for the Spring Cloud slow dependency. So let us start all the microservices. Start microservice 3 and finally start microservice 4. All the 4 microservices have started. So let us go and again hit this multiple times. So I'll be refreshing it. Now if we go here in the console logs, we can see that the Spring Cloud Slow token is attached to the logs. So first we have the application name, then we have the trace ID, then the span ID, and finally the Zipkin export flag. So we can see that the trace ID for a particular request, it will be the same. So here we can see that here this is the incoming request and this is the response that is sent back to the caller. So for this the trace ID is the same. Similarly, if we go to request 2, that is microservice 2, here we will be seeing that it will be having the same trace ID that was there in microservice 1. So in microservice 1 ending with 84. So if we go to microservice 2, here also we are having the trace ID ending with 84, and then the span ID, it will be the same for a particular request when it is executed in the same method. Similarly, here we have again the same trace ID for the this is the request, this is the response log, and this is the span ID since it is in the same method, this particular request, therefore it will be same. Whereas we'll see that the span ID is never same for the same request. So this span ID here is 2241, whereas in microservice 2 it is BCD. So span ID only in a particular method for a particular request chain it will be same. So for all the microservice that we'll see, the trace ID will be consistent throughout. So we can see that even though the Spring Cloud token and the trace ID has been attached to each of the logs, we'll still need to go to each microservice log and then correlate all the logs together. So a better approach is to use a centralized logging analysis tool, and Zipkin is one such tool. We'll be implementing it next. Zipkin is a distributed tracing system. It helps gathering timing data needed to troubleshoot latency problems in service architectures. Also, it includes both lookup and collection of this data. So the 4 microservices that we have developed, we'll be sending all the logs to Zipkin distributed log tracing server, and then we'll be analyzing these logs. To get started, first we'll need to download the Zipkin jar from Maven. So click on this link. It will give you the latest Zipkin jar from Maven. Save it and open the command prompt. Go to the location where you have saved the Zipkin jar and run it as a jar file. The command is java-jar, and then I'll be running this jar file. So Zipkin has started. If we now go to localhost 9411, this is the Zipkin UI. Next we'll be modifying the code so that it sends the logs to Zipkin. So the first change will be needing to add the Spring Cloud Starter Zipkin dependency to all the 4 microservices. So go to the pom.xml and add this dependency in all the microservices. Also in the application.properties for all the microservices we had disabled Zipkin, so just remove this property because by default Zipkin is enabled. So remove this property. You can also comment it if you want, but I'll be removing it. We are done with all the changes, so let us start all the microservices. Start the second microservice. The third. And finally the fourth microservice. So all the 4 microservices have started. If you now go to localhost 8080/microservice1, we'll hit it multiple times. Now if we go to the Zipkin dashboard and click on find traces, so here we can see all the log traces, and this is one particular request chain that had been called, so it will be having the same trace ID. It is being shown, and here we are seeing that how much time it takes for a particular request to get executed. We can select the service about which we want more details, and we'll get more details about the particular call. Hope you have understood the tutorial. The source code for this, it can be downloaded from here. Thank you.